Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 2, and this problem asks us in step 2 of mechanism 18.1, which is shown here, the loss of the proton, this proton here, shown only from one resonance structure, which is this one. It asks us to use a curly arrow mechanism to show how the other two resonance structures can be converted to the substitution product, which is this, by the removal of the proton by some sort of strong base. So we know that we have a carbocation intermediate here, and we know that because of the pi bonds here, the presence of alkene double bonds, we can have some sort of resonance structures with this carbocation intermediate such that we can move this carbocation around our benzene ring and stabilize it through resonance stabilization. So we can have one resonance structure that looks like this. And now we see that the carbocation is now in the para position. And then we can have another resonance structure that looks like this, in which now the carbocation is in the other ortho position now, the second ortho position here. So in either case, we can have the abstraction of this proton by some sort of strong base, just like how it's shown here. So in this case, we use a lone pair of electrons at our base to make a bond with a proton, making a bond. You make a bond, you break a bond. So here, the two electrons in the sigma bond will go to form a new pi bond here, making a bond. You make a bond, you break a bond, and that bond that's going to break is this pi bond here that's going to go here to now neutralize this carbocation intermediate. And you're going to get now your new pi bond here. Your electrophile is attached to that. You have your base that picked up the proton. You have the original pi bond that's on this side. And then you have the new pi bond that got kind of kicked off of this location between these two carbons and got moved over here to neutralize this carbocation intermediate. And similarly now with this molecule here, you can see that by picking up this proton, we make a new bond, we make a bond, we break a bond, so the sigma bond will break, donating 2 electrons here to neutralize this carbocation intermediate of this resonance structure, just like how it is up here, because it's the same ortho position as on the other side, on this ortho position instead of this one.